Alright friends, not a full lesson today, just kind of wrapping up, talking about parallelograms for lesson 17, module 5, lesson 17. Go ahead and take a look at page 124 in your Learn book. We've already done some of this section. We started on page 123 in class. We'll do 124 right now. I'm going to kind of combine some things, like I said. We're just sort of wrapping up. I'm going to jump down to number 3. But the instructions for number 2, we're going to kind of do some of that also. It says, draw another parallelogram below. Okay, so I'm going to draw a parallelogram. I'm going to use my ruler. You don't have to necessarily use a ruler, but I want to make sure mine looks nice and straight because we're going to be doing a lot with it. Nice straight line right here. Nice straight line right there. And hopefully we've got 2 parallels. Now, because of the way the paper is curling, it may not be perfect, but it should be all right. Then, I'm going to go ahead and turn this like that. I'm going to make a little half mark so that I can line this up properly. That might be too big, actually. Yeah, it's a little too big. That's okay. We'll pull it in a little. Now you can see I'm going pretty fast. It's not going to be perfectly exact. That's okay. If yours doesn't look exactly like this, that is also okay. But I will say, if you have a ruler, please take just a moment or two to get it at least semi-straight with those lines, because it will help with what we're going to do next. Okay? Now we've spent a lot of time talking about the angles. And if I measure the angles on this particular one that I just made, it'll be different than yours probably, but if I measure this 0, 10, 20, 30, 40, 50, 60, it's looking like 60, 65. About 60, 1, 2, 3, let's say. It's about 63 degrees. Okay. That's the acute angle. We know that'll be the same. If I measure this one's obtuse. 10, 20, 30, 40, all the way over to about, looks like about 117. Which is what it should be. Because if I take this 7 degrees and add it over here, 63 plus 7, that'd be 70. 70 plus 110 that's left, 70 plus 110 would be 180. Basically, these two added together need to equal 180 degrees. Now this would also be 63 degrees. This would be 117 degrees. Because these opposite angles are congruent, they're the same. These consecutive angles, these adjacent angles, these angles that are next to each other, they add up to make 180. And all 4 of these things, all 4 of them, would add up to make 360. Now, up above, measure the angles of the parallelogram. Please measure yours. They may be a little different than mine. But they should create 2 pairs that add up to 180. If you get to 181, 182, probably just a minor issue with the protractor, you're close enough. Okay? But for instance, this one and this one, they would add up to 180. This one and this one, they'd add up to 180. Really, I could have circled this one in blue and this one in blue. Those are 182. We've got a few options. Now, this says draw the diagonals and measure their lengths. Okay, that's interesting. Let's do that. So I'm going to go from this corner to this corner. Don't want to go over my angle measurements. It's about 3 inches. So that first one's about 3 inches. If I go from here to here, that diagonal, that one's about 2 inches. Okay, so I did that. Now it says measure the length of each of the 4 segments of the diagonals, from the vertice to the point of intersection. Okay. Well, that first one is 1.5 inches. That's 1.5 inches. Sorry, it's not showing up quite right. There we go. It cut my 3 inches exactly in half. If I measure this, same deal. From vertex to the center right there, point of intersection, is 1 inch. We say these lines, these diagonals, bisect each other. They cut each other into 2 equal pieces. Okay? Now, I'm kind of jumping ahead through a lot of this. I know it says color segments the same length and color. What do you notice? We kind of talked about that. Let's put some properties down. List the properties that are shared by all parallelograms. We're going to start with a real obvious one. They have 4 sides. I know that seems silly, but it's important. They're all quadrilaterals. They all have 4 sides. Okay, what else did we notice? Consecutive angles add up. Let's say add together. Consecutive angles add, we'll leave it as add up to 180. They add up to 180 degrees. Okay. Now, something we also noticed. Opposite angles, come on, pencil. Opposite angles are congruent. If we look up at what we drew here, 63 is opposite another 63. 117 is opposite 117. Now, I was so excited to talk about angles, I forgot there's one other thing we noticed about sides. They have 2 pairs of parallel sides. They have two pairs of parallel sides. 2 pairs of parallel sides. Now there are a couple other things we could add. All of the angles add up to 360 degrees. If we draw diagonals, the diagonals cut each other in half. They bisect each other. But really, I would say these are the big ones you want to watch for. When can a quadrilateral also be called a parallelogram? If a quadrilateral has all of the attributes, actually I'll use the word properties because that's what it says in number 4. I've been saying attributes, properties, same thing. The quadrilateral has all of the properties listed above. It is a parallelogram. It's a parallelogram. Now, this question, when can a trapezoid also be called a parallelogram? That one's a little trickier. What I've always been taught is that a quadrilateral with 1 pair of parallel lines is a trapezoid. If it has 2 pairs of parallel lines, then it's a parallelogram. They're different. However, I've also spent a lot of time talking about how things can exist in different groups, and that's what letter B is asking. When can a trapezoid also be a parallelogram? If it has all of these attributes. Trapezoids have 4 sides. Consecutive angles add up to 180. Now we've talked, it's a little more specific than that. They have to be consecutive angles on opposite parallels, but that's okay. Opposite angles are congruent. Sometimes. So if that happens in a trapezoid, then yes, it would be a parallelogram also. 2 pairs of parallel sides. If a trapezoid has 2 pairs of parallel sides, it would become a parallelogram. Most of the ones that we drew, if you look back, let's say on page 113, these only had 1 pair of parallel lines. See, there. If I had drawn, say, let's say straight across here, and had a second parallel, then this trapezoid would have been parallelogram. Now, we'll talk more about that in class. Again, we're going to continue talking about quadrilaterals. We're going to continue seeing how we can be more and more and more specific about them as we go. But I think this is a good spot to stop for today. Make sure you've completed this on page 124. If you have any questions, write them down. We're going to do a little bit of a review activity next time I see you, so be prepared for that. But if you have any other questions, email me, check in with a friend. We'll get them answered for you. All right, folks, I will see you in class. Thank you.